we have an all-new battery pack. And then something we're really proud of is the new carbon-sleeved rotors for the motor. So this is the first time that...
Have you ever stopped to imagine what it would look like if a single company suddenly pulled so far ahead that the rest of an entire industry could barely keep up? Not by a small margin, not by a single breakthrough, but by such a massive leap that every competitor is forced to ask one uncomfortable question. Who are we even competing against now? That is exactly the conversation happening after Tesla revealed its newest electric motor. When Elon Musk walked onto the stage to introduce Tesla's latest technology, many people expected another routine product launch. They anticipated a few technical specifications, some impressive performance figures, applause from the audience, and then business as usual. But this unveiling was different. Tesla didn't simply present a motor with a little more power or a lighter design. The company introduced a completely new way of thinking about electric motors. It challenges long-held assumptions about what these machines are capable of and pushes the limits of performance much further than many believed possible. One of the biggest highlights is the motor's carbon fiber sleeve surrounding the rotor, allowing it to safely spin at speeds exceeding 20,000 revolutions per minute. Combined with Tesla's advanced engineering, this technology enables astonishing acceleration, sending a vehicle from 0 to 60 miles per hour in under 2 seconds. If these capabilities continue to prove themselves in real-world applications, Tesla has raised the standard for the entire electric vehicle industry. What makes this story even more fascinating is that Tesla isn't keeping the technology locked away. For years, the company has maintained an open patent policy, allowing other manufacturers to study many of its innovations. In theory, any automaker can examine Tesla's engineering and attempt to build something similar. So why doesn't that erase Tesla's advantage? Knowing how something works is very different from mastering the expertise, manufacturing precision, supply chain, and years of experience required to reproduce it successfully. It's a bit like having the recipe for a world-famous dish. You can read every ingredient, but creating the same result is another challenge entirely. That raises an even bigger question. What does this mean for the millions of people planning to buy an electric vehicle over the next few years? Can established automakers close the gap? Or are we entering a period where Tesla strengthens its position as the industry's leading innovator? Those are the questions we'll explore throughout this video. Rather than simply reporting the latest headlines, we'll look at why this technology matters, how it could reshape the future of electric transportation, and whether it truly represents the next major turning point for the automotive industry. To understand why Tesla's latest motor has attracted so much attention, we need to go back nearly 2 decades. In 2003, engineers Martin Eberhard and Mark Tarpenning founded Tesla Motors in San Carlos, California. At the time, the idea of a successful electric car company seemed unrealistic to much of the automotive world. Electric vehicles were widely viewed as slow, impractical, and uninspiring. Most offered limited driving range, modest performance, and little appeal beyond a small group of environmentally conscious buyers. The prevailing belief was that gasoline-powered cars would continue to dominate for decades. Few people imagined electric vehicles could ever rival traditional cars in speed, design, comfort, or driving excitement. Then, Elon Musk entered the picture. In 2004, Musk invested in Tesla and became the company's largest shareholder. While the financial support was important, his vision proved to be even more significant. He believed electric cars shouldn't exist simply as environmentally friendly alternatives. Instead, they should be vehicles that people genuinely desire, cars that are beautiful, fast, technologically advanced, and exciting to drive. That philosophy shaped Tesla's future. In 2008, Tesla introduced the original Roadster. Built on a Lotus chassis, it demonstrated something the automotive industry had largely dismissed. An electric motor could deliver genuine sports car performance. Drivers didn't just see impressive numbers on paper. They experienced instant acceleration that pushed them back into their seats the moment they pressed the accelerator. Tesla had proven that electric power could compete with, and in some cases outperform, traditional gasoline engines. The momentum continued. In 2012, Tesla launched the Model S, a luxury sedan that challenged expectations with its minimalist interior, large touchscreen display, over-the-air software updates, and remarkable performance. Established luxury brands suddenly found themselves facing an entirely new kind of competitor. Tesla expanded its lineup with the Model X, featuring distinctive falcon wing doors, followed by the more affordable Model 3, which helped bring electric vehicles into the mainstream. Then came the Model Y, one of the world's best-selling electric SUVs, and later the futuristic Cybertruck, whose unconventional design sparked conversations across the industry. Each new product forced traditional automakers to respond. Ford introduced the Mustang Mach-E. General Motors invested heavily in its Ultium platform. Volkswagen accelerated development of its ID family of electric vehicles. Hyundai and Kia quickly emerged as serious competitors in the rapidly growing EV market. As competition increased, many analysts predicted Tesla's best years were behind it. Some argued that once the world's largest automakers fully committed to electric vehicles, Tesla would lose its unique advantage. They believed the company had already reached its peak. But that prediction overlooked something important. While competitors focused on matching Tesla's previous achievements, Tesla continued investing in the next generation of technology. Instead of standing still, the company was preparing for another major leap, one that much of the industry didn't see coming. And to understand why this latest breakthrough could have such a profound impact, we need to look at the heart of the innovation itself. Because everything begins inside the electric motor that could redefine the future of transportation. When Elon Musk introduced Tesla's new Plaid motor, featuring a carbon fiber sleeve, many people had the same initial reaction. That sounds impressive, but is it really a major breakthrough? The answer is yes. And the reason goes far beyond what you can see from the outside. To understand why this technology matters, we need to look inside the most important component of any electric vehicle, the motor's rotor. The rotor is the spinning part inside the motor that converts electrical energy into mechanical movement. It is the component responsible for creating the force that ultimately moves the vehicle forward. In most electric motors today, rotors are built using combinations of steel and copper. These materials have been used successfully for many years, but they have a physical limitation. As the rotor spins faster and faster, the forces acting on it become extremely intense. The faster it rotates, the greater the centrifugal force pulling the material outward. At very high speeds, the structure begins to experience stress. The rotor can deform, temperatures increase, efficiency drops, and the entire system becomes harder to control. Tesla's solution sounds simple, but achieving it required incredibly advanced engineering. Surrounding the rotor with a layer of carbon fiber. Carbon fiber, the same lightweight and incredibly strong material used in Formula One racing cars, aircraft, and aerospace applications, has an exceptional strength-to-weight ratio. Compared with traditional metals, it is lighter, while also being much stronger when dealing with pulling forces. By wrapping the rotor with carbon fiber, Tesla creates a powerful stabilizing effect. The carbon layer applies continuous external pressure, often called preload, which helps keep the rotor tightly controlled even when it reaches extremely high speeds. The result is a motor capable of spinning beyond 20,000 revolutions per minute, a speed that is far beyond what many conventional electric motors can achieve. And that extreme rotational speed directly contributes to the incredible performance drivers experience. This is one of the reasons the Tesla Model S Plaid can accelerate from 0 to 60 miles per hour in under 2 seconds. Not long ago, that kind of acceleration was reserved for ultra-expensive hypercars from brands like Bugatti and Koenigsegg. Tesla brought that level of performance into a vehicle that is still practical enough for everyday use. But raw speed is only one part of the story. The bigger advantage is efficiency. Because the rotor is lighter and operates more effectively, the motor requires less energy to produce the same amount of power. With the same battery capacity, the vehicle can potentially travel farther. The cooling system faces less stress, and the battery experiences less strain over time. All these improvements work together. A more efficient motor reduces energy consumption. Lower energy demand improves range. Reduced heat generation improves reliability. Better efficiency can also reduce operating costs. It creates a chain reaction where every improvement supports the next one. Another important factor that often gets overlooked is thermal stability. Heat is one of the biggest enemies of electric motors. As temperatures rise, different materials expand at different rates. Over time, uneven expansion can create tiny imbalances inside the motor, leading to increased wear, reduced efficiency, and performance loss. The carbon fiber sleeve helps solve this issue because it does not behave like traditional metals when exposed to temperature changes. It maintains consistent pressure around the rotor, helping the entire system remain stable even under extreme conditions. So this is not simply Tesla's fastest motor. It is a design focused on achieving multiple goals at the same time: higher speed, greater durability, improved efficiency, and better long-term stability. At first glance, wrapping carbon fiber around a metal rotor might seem like a small engineering detail, but this small detail could be one of the biggest reasons Tesla has pushed electric motor technology forward. And the most surprising part is that making this technology work was far more difficult than it appears. The challenge comes from the fact that carbon fiber and metal do not behave the same way when temperatures change. Steel, copper, and carbon fiber all expand and contract at different rates. If the carbon layer is applied incorrectly, the extreme heat generated during operation could cause problems. The carbon fiber could separate, crack, or fail completely. At normal speeds, these issues would already be serious. But at more than 20,000 revolutions per minute, even a tiny imbalance could create catastrophic consequences. To overcome this challenge, Tesla had to develop an entirely new manufacturing process. The company created highly advanced robotic systems capable of applying carbon fiber around the rotor with microscopic precision. Not millimeter-level accuracy, micrometer-level accuracy. That means controlling measurements thousands of times smaller than a millimeter. The system must precisely manage multiple factors at the same time: the tension of the carbon fiber, the environmental temperature, the speed of the wrapping process, and the exact angle at which each layer is applied. After the process is complete, advanced laser measurement systems inspect the rotor to confirm that everything is perfectly aligned. Even the smallest deviation can affect performance. This is what makes Tesla's achievement so significant. The innovation is not just the idea of using carbon fiber. Engineers have known about carbon fiber's advantages for years. The real breakthrough is creating a manufacturing process that can apply it with the level of precision required for a motor spinning at extreme speeds. And that is where Tesla's advantage comes from. Not only the technology itself, but the ability to manufacture it at scale. Before a Tesla motor ever reaches a vehicle, every rotor goes through individual inspection to make sure it meets strict quality standards. And this is the most important point to understand. Tesla patented its carbon fiber sleeve technology and made those patents available for others to study. Any company in the world can examine the designs, analyze the engineering, and understand the basic principles behind the innovation. But knowing the blueprint is not the same as being able to build the machine. A competitor can understand Tesla's idea, but that does not mean they have the manufacturing expertise required to reproduce it. They do not have the artificial intelligence systems trained through thousands of experiments to determine the perfect amount of carbon fiber tension. They do not have years of production data, testing procedures, and quality control systems that Tesla has developed. And even if they somehow managed to solve those challenges, they would still face the biggest obstacle of all: scaling the technology. Building a few advanced motors in a laboratory is one thing. Producing tens of thousands of them every month with consistent quality is a completely different challenge. This is where Tesla's strategy becomes interesting. Opening patents was not simply an act of generosity, it was also a statement of confidence. Tesla was essentially showing the world, you can see how we built this. You can study every detail, but catching up requires much more than knowing the idea. Because in the automotive industry, innovation only matters if you can manufacture it efficiently and deliver it to millions of customers. However, no technology is perfect, and a balanced analysis also requires looking at the challenges Tesla still faces. The first major challenge is production cost. Creating a carbon fiber-wrapped rotor with micrometer-level precision is extremely expensive. Each motor requires advanced machinery, careful inspection, specialized materials, and a highly controlled manufacturing environment. Although Tesla continues to increase production, these advanced motors still cost significantly more to produce compared with traditional electric motors. This creates an important question. Will Tesla eventually bring this technology into more affordable vehicles like the Model 3 and Model Y, or will it remain limited to premium performance models? The second challenge is financial pressure. Tesla has faced increasing competition, changing market conditions, and pressure on profit margins. The global electric vehicle market has become much more competitive, especially as Chinese manufacturers continue expanding. Companies such as BYD, SAIC, and NIO are no longer small experimental startups. They are producing vehicles at massive scale, often with lower production costs, and they are aggressively entering international markets. In a price war, having the most advanced technology does not always guarantee success. Cost efficiency, manufacturing capacity, and customer demand matter just as much. The third challenge is Tesla's dependence on Elon Musk. There is no doubt that Musk has played a major role in Tesla's vision, branding, and technological direction. His ability to attract attention and push ambitious ideas has helped transform Tesla into a global company. However, that close connection also creates risks. Controversy surrounding Musk's public statements, activity on social media, and delayed promises have sometimes affected public perception of the brand. For many older and more experienced buyers, purchasing a vehicle is not only about acceleration numbers or futuristic technology. Trust, reliability, and confidence in the company behind the product are equally important. The fourth challenge is charging infrastructure. Tesla's supercharger network has been one of its strongest advantages, especially in markets like the United States. A reliable charging network helped remove one of the biggest concerns people had about switching to electric vehicles. However, as Tesla begins allowing other manufacturers to access its charging network, that advantage becomes less exclusive. At the same time, charging availability remains a major concern in regions where infrastructure is still developing. Many potential buyers continue to worry about whether they can easily charge their vehicle during long-distance travel. The fifth challenge is autonomous driving technology. Tesla has spent years developing its full self-driving system and has made significant progress in driver assistance technology. However, the technology has not yet reached the fully autonomous future that many people expected based on earlier predictions. That difference between expectation and reality creates a credibility challenge. When promises are delayed, customer confidence can be affected. None of these challenges erase Tesla's achievements with its electric motor technology. The carbon fiber sleeve design represents a major engineering accomplishment. But the reality of the automotive industry is that groundbreaking technology alone does not guarantee market dominance. Success requires many pieces working together: manufacturing, cost control, customer trust, infrastructure, and long-term business strategy. And this is exactly why the competition is becoming even more intense. Tesla is not the only company trying to define the future of electric vehicles. When Tesla introduced its plaid motor technology, competitors responded in different ways. Some remained quiet. Some questioned its importance. Others immediately accelerated their own research and development efforts. Let's look at some of the companies trying to challenge Tesla. One of the most impressive competitors from an engineering perspective is Lucid Motors. The Lucid Air Grand Touring performance has demonstrated remarkable efficiency and range, with capabilities that place it among the most advanced electric vehicles available today. Its electric drivetrain shows a high level of technical innovation and engineering precision. However, Lucid faces a major challenge: scale. The company currently produces and sells far fewer vehicles compared with Tesla and focuses primarily on the luxury segment. That market can showcase impressive technology, but it is much smaller than the mainstream automotive market. Without large-scale sales and stronger financial resources, developing the next generation of electric motors and competing with Tesla's manufacturing power becomes much more difficult. Lucid may have extraordinary engineering talent, but turning that talent into a global revolution requires something every automaker needs: the ability to produce millions of vehicles efficiently. Rivian is taking a different approach. Instead of competing directly with Tesla across every category, the company is focusing on electric trucks and SUVs designed for adventure and outdoor lifestyles. The brand has built a strong identity, developed a loyal customer base, and received major financial backing from companies like Amazon. However, when it comes to pure electric motor technology, Rivian is still relying on a more traditional approach compared with Tesla's latest innovations. And as Tesla continues advancing with each new generation of technology, that gap could become increasingly difficult to close. Ford represents one of the most interesting cases among traditional automakers. Tesla is no longer just an electric vehicle manufacturer. It is becoming a broader energy and mobility technology platform, one that could influence transportation, electricity, and industrial systems throughout the 21st century. While many traditional automakers are focused on building better electric vehicles, Tesla appears to be pursuing a much larger goal: creating the foundation for a future where transportation and energy no longer depend on fossil fuels. These are two very different approaches. One is about creating competitive electric cars. The other is about building an entire ecosystem around clean energy, advanced technology, and global infrastructure. And perhaps the ultimate demonstration of Tesla's motor technology will come through the long-awaited Roadster 2.0. Tesla's next-generation electric sports car has been announced multiple times and delayed several times. But if it finally arrives with the performance figures Tesla has promised, acceleration from 0 to 60 miles per hour in under 1 second, a range exceeding 600 miles, and the full integration of Tesla's newest motor technology, it would represent far more than just another fast car. It would become a powerful statement about what electric vehicle engineering is capable of achieving. It would show the world that electric vehicles are not simply alternatives to gasoline cars. They can redefine the limits of performance itself. The competition is far from over. But Tesla has once again shown that it is not only competing within the existing rules, it is attempting to change the rules of the entire game. Looking back, this journey is remarkable. From the first Tesla Roadster in 2008 to today's advanced motors featuring carbon fiber technology manufactured with micrometer-level precision, Tesla's evolution has been a story of constant experimentation and ambitious engineering. But there is one important point we need to remember. Tesla's plaid motor technology is real. Its performance achievements are real. The engineering advantage Tesla currently holds in electric motor development is also real. However, history has repeatedly shown that having superior technology does not always guarantee commercial success. Technology alone does not decide the winner. Consider the past. Betamax was widely considered technically superior to VHS, yet VHS became the dominant format. BlackBerry created some of the most advanced business phones of its era, but the arrival of the iPhone completely changed consumer expectations. Nokia once controlled the global mobile phone market, only to lose its position when the industry shifted in a new direction. The same lesson applies to electric vehicles. The EV industry is still developing, and the final winners have not been decided. Consumer preferences are changing. Governments are adjusting EV policies and incentives. Battery technology continues improving, bringing costs down and potentially reducing the advantages of companies that currently have a lead. Global supply chains are also becoming increasingly important. Trade policies, tariffs, and geopolitical changes could influence which companies succeed and which struggle. So yes, Tesla has achieved something remarkable with its latest motor technology. But does this mean the electric vehicle industry has already been decided? Are competitors truly unable to catch up? Or are companies around the world quietly developing their own breakthroughs that could change the balance of power? The truth is, nobody knows for certain. Anyone who claims they can predict exactly how this industry will unfold years into the future is making a much bigger claim than the evidence allows. What we do know is that the electric vehicle revolution is entering one of the most important periods in automotive history. Competition is increasing. Engineering breakthroughs are happening faster. Companies are fighting for lower costs, better batteries, stronger charging networks, and smarter vehicle technology. Everything happening today is shaping the future of transportation. The decisions made over the next 3 to 5 years could influence the direction of the industry for decades. So what do you think? Has Tesla created such a large technological advantage that competitors will struggle to catch up? Or will companies like Lucid, BYD, traditional automakers, and even unexpected new players introduce innovations that change the competition again? Share your thoughts in the comments, especially if you already own an electric vehicle or are considering buying one. Real-world experiences and opinions are an important part of understanding where this industry is heading. If this video helped you see the electric vehicle revolution from a different perspective, support the channel by liking the video. And if you want more deep analysis about Tesla, technology, energy, and the innovations shaping the future, subscribe and stay connected.